Hello guys, welcome to this video on Introduction to Docker. So what is Docker? Docker is a platform that enables developers to create, deploy and run applications in containers. And containers are lightweight, standalone and portable environments that encapsulate an application and its dependencies, making it easier to develop, test and deploy software across different computing environments. So basically, Docker is a tool designed to make it easier to create, deploy, and run applications by using containers. Docker eliminates the confusion that comes when a developer has been working on their local machine on a project. As soon as it's deployed to a new environment, the application won't run. So with Docker, your development environment will be exactly the same as your production environment and exactly the same as everyone else development environment. This helps us alleviate the problem of it's broken on my machine. So now let's see some components and architecture of the Docker. So first is Docker client. So the Docker client is the primary user interface for interacting with Docker. It is a command line tool that allows user to send commands and requests to the Docker daemon. Users issue Docker commands via Docker CLI to build, run, manage, and monitor containers and images. So Docker daemon. The Docker daemon is a background service or process that runs on the host system. It manages Docker containers and handles container operations. The daemon listens to Docker API requests from the Docker CLI and external tools, then executes those requests by creating, running, or managing containers. Now we have Docker images. Docker images are read-only templates that serve as the foundation for creating any containers. Images contain application code, libraries, and dependencies required to run an application. These images are stored in a registry, and users can create their custom images by defining instructions in a Docker file. So Docker registry is a repository for sharing and distributing container images. The most common registry is Docker Hub, but organizations can also set up private registries for image distribution. Users can pull images from registries to their local system, and also they can push images to registry. And then we have Docker containers. The containers are runnable instances of Docker images. Containers encapsulate an application along with its dependencies, runtime environment, and configurations. Containers are isolated from each other and share the host OS kernel. So next we have volumes. Volumes can be mounted into containers to store data that needs to survive container restarts or to be shared among multiple containers. Now let's see some commands and understand the workflow of this architecture. First we have Docker file. Now let's understand what is Docker file. Uh, a Docker file is a text file that contains a series of instructions for building a Docker image. Here is an example of this Docker file. The Docker file looks like this. You'll use a Docker file to create your own custom Docker image. In other words, to define your custom environment to be used in a Docker container. You'll want to create your own Docker file when existing images won't meet your project needs, which means the learning about Docker files is an essential part of working with Docker. So, Docker will execute Docker file when you issue an Docker build command. Let's understand these commands. Every Docker file must start with from. The idea behind this that you need a starting point to build your image. It can be from scratch or from an existing image available in the Docker registry. And env provides the default values for variables that can be accessed within the containers. The run command is used to execute a command and will wait till the command finishes its execution. And since the most of the images are Linux based, a good practice is to set up a directory you will work in. That's the purpose of a working directory line. It defines a directory and moves you in. And next we have add. The add command is used to copy files and directories from the host machine into the Docker image being built. And if your app needs to be reached from outside the container, you must open its listening port using the expose command, this command. And the cmd or the entry point command defines the default command that runs when a container is started. So in this way you can create your own image from Docker file. Now let's see some commands and understand the workflow of this architecture. So here is the docker build command. Docker build command is used to build the image in the Docker host, or you have to give here the path, docker build path here. And so when we trigger this command, Docker client will communicate with the Docker server and checks if the image is already available in the image section. If the image is already available there, then it will use that image. But if it is not available, then it will build the image and store the image here in the image section. Now we have docker run command. So docker run command is used to run the container. And when we trigger this command again, client communicate with the host and it checks if the image is available or not. Now the image is available here, so it will build the container from that image. So next we have docker pull command. This command is used to pull the images from the Docker repository. When we trigger this command, here this command is docker pull python. When we trigger this command, it will check if the Python image is available in the image section or not. If not, it will pull the image from the Docker repository and place it on your images section. Now we have docker push command. Docker push command is used to push your own images to the Docker repository. And when we trigger this command, it will push the Ubuntu image to the Docker repository. Now again, if we trigger the run command for our Python image, if we trigger the run command for our Python image, it will start a container from this Python image. So these are some basic components and architecture of the Docker. Now let's see when to use Docker. Microservices architecture. Docker containers are well suited for microservices based applications. Each microservice can be packaged as a separate container, making it easier to manage, scale, and update individual component of your application independently. And scalability. Docker containers can easily scaled up or down to handle changes in traffic. Container orchestration platforms like Kubernetes, Docker Swarm, and others can automate container scaling based on demand. And legacy application modernization. Docker can help modernize and extend the lifespan of legacy application by containerizing them. This allows for easier maintenance, scalability, and integration with modern services. And we have hybrid and multi-cloud environments. Containers are highly portable. You can run the same containerized application on different cloud providers or on-premises infrastructure, making it easier to adopt a hybrid or multi-cloud strategy. And we have security and isolation. Containers provide a level of isolation between applications, enhancing security. So that's it for this video. Thanks for watching this.